going to do a few questions from Assess 13 to finish off the unit, finish off that chapter. We're dealing with simultaneous equations, and I'll just take some random ones. We'll do a fine selection of each kind. From question 1, I'm going to do the very first one just to remind you how these are done. We've got 3a minus b comes to 11, and we've got 2a plus b comes to 9. Now, I chose this one, it's the most basic one you can get. We've got a single b, top and bottom, that we can eliminate by addition, I believe. Yeah, if we add, we go minus b plus b is 0, that's gone. We can just add easily now, 3a, 2a, 5a, 11, 9, 20, a is going to be 4. Again, substituting it in the easiest equation, probably if we put it into the bottom one right there, that should be quite easy for us to do really. So let's have a look. I've got 2 lots of 4, plus b is 9. I've got 8 plus b is 9. Straight away b must be 1. And I'll do d as well, just to show you that sometimes none of the terms in the equation are the same. So I'm choosing this one for that reason, and I've got m minus n equals 1. Okay, we can either multiply by 3 along the bottom to get 3 m's, or multiply by 2 along the bottom to get 2 n's. My tendency will be to multiply by 2 to we're dealing with smaller amounts, so we just rewrite the equations. We've got 3m plus 2n equals 28. I just multiply by 1 throughout. Doubling up, we've got 2m minus 2n equals 2. Again, don't forget to multiply the parts after the equation. And in order to eliminate the 2n's and the minus 2n's is to add them a bit like this one here. So 2n plus minus 2n, they've gone. Just add the m's now. So 5m is 30, from which we get m is 6. Substitute in the bottom equation. It looks very, very easy, doesn't it? Stick it in there, and we've got 6 minus n is 1. I can see straight away n's got to be 5, clearly so. And that simultaneous equation's done. Let's just do a couple of the really dangerous ones, and these ones involving one linear equation and one quadratic equation. This one's going to run along, which is C. That's going to be y plus 3x is 7, and y equals 4x squared minus 5x plus 1. And that's the quadratic part, so linear, quadratic. If I rearrange the top one, I'm going to get y equals 7 minus 3x. So what's easy now is that we can substitute this part into this y here, and just perform an equation with x, and in doing so we eliminate the y, so it's great. So I've got 7 minus 3x equals 4x squared minus 5x plus 1. Bring everything over to the right hand side. 0 equals 4x squared minus 5x plus 1. Take away the 7, add the 3x, tidying up 4x squared. We've got minus 5x plus 3x is minus 2x. 1 take away 7 is minus 6. Dividing everything through by 2, because all the factors there are even. So we've got 0 equals 2x squared minus 1 minus 3. Factorising as follows. We have 2x and x. The only way to make 3 is 1 times 3, and I'm going to put a 1 there and a 3 there, because 2 times 1 is 2, and 3 times 1x is going to be 3x. I can subtract them to get a single minus 1x there. That should be minus 1x. Let's slow down a little bit. Okay, that's good. Right, let's do the signs now. I want that to be positive and that to be negative. So what we got there? 2x minus 3x is minus 1x, and what do we got here? Minus 3 times 1 is minus 3. Now, you don't really need the minus 1 there, but obviously just to make it stand out for teaching purposes, I could leave it in there. It's getting rather untidy, isn't it? Right, that's good. Right, factorised, done, solve. So x equals 3 over 2. In other words, x is 1.5. Here x equals 1. Now substituting in an easy part of the equation to find the corresponding y values. We'll do that right now. So using x equals 1.5, we shove it in there. We've got y equals 7 take away 3 lots of 1.5, which is 7 take away 4.5. That's right, so which gives us an answer of 2.5 for y. So that's the corresponding value for that x there. And here x equals 1, very easy. Y equals 7, take away 3 lots of 1, which means 4. So here we go, that's the full set of values there, and that's that one solved. I'll do the last one because it was really tricky, very busy in fact it looks, so I'm going to go for it anyway and leave it on video. I've got 3x minus 2y is 1, and I've got y equals, here's the quadratic part, 2x squared plus 5x minus 8. Now there's nothing easy here. If I try and convert this into the form of x equals, it's going to get really messy, and besides it means I have to substitute all those y's where the x is. It's complicated. A lot easier to convert this one into the form of y equals. So what have I got? I've got 3x minus 1 equals 2y. I just brought this over and added this over and subtracted. Now I've got to divide by 2. The other option of course is to multiply all of this by 2, so I end up with 2 y's. I'm just feeling it's a better strategy. Otherwise I have to divide this by 2, end up with 1.5 x's and minus a half at the end. It's really ugly. So I'm going to double this up and call it 2y, just to show the examiner what my brain did. So doubling up, I've got 4x squared plus 10x minus 16. And that of course equals this part here, doesn't it? Alright, because 2y is 2y. Let's just put a black on that so you can see it. That is that, and that is that. So I'm now going to shove this part in there, then we can just get on with it. So here we go. 3x minus 1 equals 4x squared plus 10x minus 16. Stop working there. That's it, minus 16. Bring it all over to the right hand side where the bulk of the terms are. Minus the 3x and plus the 1. Tidying up, I've got 4x squared and 10 take away 3, 7x's, minus 16 plus 1 is going to be minus 15. No common factors there. I've got to try and factorise this horrible little thing. The trouble with this is I can even go, split up into 2 and 2 and 4 and 1. That's the usual problem. If we go for 2 and 2 to begin with, just to see how it goes, we make 15 by going 5 and 3, or 15 and 1. So let's try 5 and 3, or 3 and 5. Let's see how that works. So 6 and 10 won't give us a gap of 4, a gap of 7, will it? So 6x, 10x, can't get 7x out of that. So I'm guessing it should in fact be a 4 and a 1. So let's just try that. So 4x and a single x. What do we got? 12 and 5. Yeah, 12x, 5x will give me a 7x, so that's not a problem. So that becomes 12x, that becomes minus 5x, and that gives us 7x right there. And minus 5 times 3 is minus 15. I know I've got it right. Right, each little bit's worth 0, so x equals 5 over 4. In other words, 1 and a quarter. Here, x equals minus 3. Let's substitute back into the easiest equation to find the value for y. Well, 2y. We'll halve it in the end. So here we go. Let's work up here. It's quite complicated. So I've got 3 and 1.25 x's. Take away 1 makes 2y. That's going to be, oh, that's awful. That's going to be 3 and 3/4 take away 1 equals 2y. So 2y is going to be 2 and 3/4. And now I've got to divide that by 2. Lovely. So take it over and divide by 2. In other words, multiply by a half. So how do you do this then? What's half of 19? 11. 11 over 4 times a half. That gives us 11 over 8, and that becomes 1 and 3/8. That is quite hard, isn't it, messing around with that? I mean, not only have we got to get a complicated quadratic and linear equation to merge and get some answers, we've got to play with fractions as well so early in the morning. So put that down there, and now work with the other one. Should be easier if it's minus 3. So I've got 3 lots of minus 3. Minus 1 is 2y. So it must be 2. So minus 9 minus 1 is 2y. 2y is minus 10. Y is minus 5.